So we are continuing with our lab exercise on spatial information science. I'm Shahab Fazal and I'm a faculty here in the Department of Geography at Aligarh Muslim University. If you recall, in the last session, we looked into how non-spatial tabular data can be brought into spatial information system in spatial format. There we learned to draw census data, changing its format, and also to join the desired columns from different tabular data sets. So we learned different methods of bringing data into spatial information system. Today we would look into the spatial queries using the QGIS. As I'm saying that we have already seen attribute querying in previous tutorial. Now we will learn about spatial querying. In the previous session, we talked about attribute querying. Today, we would be looking into spatial querying. That means from the map which is being displayed, how we can bring out some inferences out of it through spatial queries. So spatial query selects geographical features based on location and spatial relationships. Now, how this location and spatial relationship can be drawn? It is through the attribute information which we have linked to the table or to the geographic location. So that's why we are saying that spatial query selects geographical feature based on location as well as spatial relationship. So here we are talking about the attribute information. Through attribute information which are being represented in the map, we would be putting some query and we will get the result out of it. So it uses spatial logic or spatial relationship among the data sets such as, if you recall, we discussed in the topology part, adjacency, intersect, containment, within, etc. So you can recall that what these terms means. Intersect means if there are two entities, whether it is point, line or area, either whether they are intersecting each other or not, or if there are some entities, again point, line and area, how close or how far it is from any other polygon or any entity, aerial entity. Containment means that how any area entity or polygon entity or any geographical entity, how it is surrounded by different other entities or other phenomena. So that would be containment, etc. So you see, what we have learned theoretically in topology, now we would be visualizing, and also on the basis of retrieving some information out of the relationship, spatial relationship which exists among the different area entity, point entity, line entity, we would be drawing some inferences out of it. That's what this lab we would be looking into it. So in this lab, we will focus on building spatial queries to retrieve the information in a useful form, which would be useful for us, and export the result as a new shapefile. You see, if you recall again, I would say that during the theoretical part, we have highlighted that how some of the inferences which might not be directly visible in our spatial information, through the attribute relationship, which we can draw a new relationship. And that relationship, which in this exercise we would be displaying, and then we would be converting it into a new data set. So what information which was not actually visible in the spatial information, now we would be not only identifying those relationships, those attributes would be highlighted, and on the base of those information, we would be converting our data, our information, and we would be drawing, we would be projecting a new data set from the earlier data set which was available with us. So that kind of spatial relationship will draw new inferences. That's the point which I want to make. And as I am saying that we would be retrieving the information a new information out of the data set which we have, and then the new information would be displayed and presented as a new shapefile. So a new data set would be created. So in this exercise, we want to find out, the objective is from a state map, we would be looking into the linear entities of roads, and then there is another linear entity which is river. So we would be trying to find out which are the roads which are crossing over the river, and we would also try to highlight as to how the road and river vector data, these are available in the older data set. Some of them, they might be intersecting, that means the roads are passing through the river, and out of that, how many of them they are crossing the river, the roads are crossing the river with the bridges, through the bridges. So this way we would like to extract out some information, and for that matter we have the data set with road of Maharashtra and river of Maharashtra. These are the two line entity in the form of shapefile which is available with us. So we will start with the QGIS application, and we will open the desired shapefile in the map canvas. You know how to open the maps. So we will go to the main menu bar, we would go to vector, within the menu bar there we would click on Spatial Query, and then when the Spatial Query would drop down menu will come, we have to click on it, something like this. So we have selected the water bodies, river Maharashtra and road Maharashtra we would select, and then we will go to vector. You see here in the menu bar, there we will go to Spatial Query, and then also again we have to click on the Spatial Query. That is how in the QGIS you have to use the menu bar and different items which are existing in when you drop down the menu, and different other sub menu are appearing there. So this will result into this kind of window will come up. So Spatial Query window will open. This window contains 4 sections. So the source feature needs to be added as the first step. So you just go to the first step would be to select source feature from, and the source feature is the feature on which spatial query is to be carried out. So this is very important, that you need to select the appropriate file, appropriate folder, appropriate map on which we want to perform the spatial query. So here you have to select road Maharashtra or road Maha, which has been named as road Maha. In this query it will be road dataset. So click on the arrow next to the vector layer name to access the drop down list of vector file loaded to map canvas, and select the road Maharashtra from the list as it is being displayed over here. So this way you need to select the appropriate map on which we want to make the spatial query. Now in the second step, where the feature, so where we want to look into this particular aspect where my cursor is moving. So there are many other options where the feature crosses. So there can be many other option also. It can be over the feature, crosses the feature, intersect the feature. So depending on your kind of spatial query, you have to select. So we are selecting where the feature, it is to be selected as crosses. So what we want to put as spatial query, road Maharashtra which crosses, then reference feature. Now, another line feature, as we have said, it is the river. So river Maharashtra I would select. So reference feature of river Maharashtra. When we select this, and then we would apply. So what happens? First step is to select the source feature on which we want to perform the spatial query. Then second would be, what would be the operation you want to do? What would be the classification which you want to make. So here we select the spatial relationship criteria which carry out the query. So to find out the road crosses over rivers, crosses criteria is to be selected. Therefore select crosses criteria from the scroll down list, and then you have to look into the reference feature, and then you have to, so reference feature is in the third step. So second step was the crosses, which was the operation which we wanted to do. Now the third step would be to locate the reference feature, or so road which crosses what. So there, the third step, we will choose a vector layer which we would be using our reference layer, and in this case it would be River Maharashtra layer as the reference layer. So in the fourth step, we use the result to select and create new selection. So this is appearing here. The next step would be, third step was to identify the reference feature. So in the previous slide also, and here again I am emphasizing that we should select the another feature as River Maharashtra, and then we would be creating a new selection, and then we will, when all the inputs are filled out, then we would be selecting apply. So when we will do this, so now we will be presented with the spatial query window. Now you see this kind of window would appear. So now the feature satisfying the criteria would be appearing in the yellow color. So here you can see, here there are 2,700 total river crossing the roads, but out of that, what query we have posed, there are about 1294 are the total result query. So if you see the map canvas, the lines marked in yellow are road segments which crosses over the rivers. So by this query, we can find out the road segments which passes over the river, and also we can check whether bridges are existing on these road segments or not. That is another supplementary query which we can make. So here you see, this way we are getting everything what we did. So this in spatial query dialog box, this is the source feature, then this is what operation we wanted. So it is crosses. The another reference feature is River Maharashtra, and then we are also saying that the create new selection, and we get to know that these are the selected features which have come up. And when we click on apply, we will be presented with the spatial query window, and the features satisfying the criteria will be marked in yellow color. If you see the map canvas, the lines marked in yellow are road segment which crosses over the rivers. So this would appear like this. So you see, within the state of Maharashtra, these yellow lines, they are crossing the road network. That is what we get from our spatial querying. You can see here that how map is transformed, and all the yellow lines, they are the roads which are crossing the rivers. So this way, the spatial query window gives us the number of selected features. As I have pointed out, some 1200 are the selected features. Now we can save these selected features to a new layer with the help of these icons. Any of these icons, if we can select, so we will create a new layer. So here it will be appearing as Road Maharashtra crosses River Maharashtra, and we will select it, and when we click apply and close, then a new data layer would be with us, and that will give us, so when we will click apply, this will come up. Now here it is one more important feature which you should take into consideration, and that is that when you save the layer into desired location, it is very important to deselect all the selected features before proceeding to the next query. You see, clicking on deselect features from all layer tool from the attribute toolbar is very important. Why? Because otherwise all the time whatever spatial query we have made, it will connect it with the previous data sets. So when we are saving it as the product of our spatial query, we should be deselecting, disconnecting from the original data. So then these data would be only linked to the newer relationship, newer shapefile which we have created out of our original data. So that is very important. Otherwise, the volume of data would continue to increase, and moreover, if you make any change in our original data, any modification if we make, then it will have its bearing and its implication on this information also. So that way it is better to disconnect them. So that is why it is very important to deselect the features from all layers, so that whatever new spatial information has come up with our spatial query on original map or original data, then we should be disconnecting it and produce a newer information, spatial information out of it.